Video lecture, Chapter 8, Dental Imaging. Purpose: to present the basic concepts of digital imaging, introduce the types of digital imaging, and discuss the advantages and disadvantages of digital imaging. Basic concepts. To record dental images, no film or processing chemistry is used. Uses an electronic sensor and computerized image system that produces X-ray images almost instantly on a computer monitor. Terminology: analog image, bit depth image, charge coupled device, digital imaging, digital image, digital subtraction, and digitize. Direct digital imaging, indirect digital imaging, line pairs millimeter, pixel, sensor, storage, phosphor imaging. Purpose and use: to generate images that can be used in diagnosis and assessment of dental disease, to detect lesions, diseases, and conditions of the teeth and surrounding structures, to confirm or classify suspected disease, to localize lesions of foreign objects, to provide information during dental procedures, to evaluate growth and development, to illustrate changes secondary to caries, periodontal disease, or trauma, to document the condition of a patient at a specific point in time, and to aid in the development of clinical treatment plan. Fundamentals. Digital imaging is a method of capturing an image using a sensor, breaking it into electronic pieces, and presenting and storing the image using a computer. The image is used to describe the pictures that are produced. A sensor is placed inside the mouth. The electronic signal is digitized. Radiation exposure. Digital imaging requires less radiation exposure than film-based imaging. The typical sensor is more sensitive to X-rays than conventional film. Exposure times are 50 to 90% less than required for conventional radiography. Equipment will include an X-ray unit, a sensor, and a computer. X-ray unit. Most digital imaging systems use a conventional dental X-ray unit as the X-ray radiation source. The X-ray unit timer must be adapted to allow exposures in a time frame of 1/100 of a second. A sensor is a small detector that's placed in the mouth of the patient and used to capture the dental image. It may be wired or wireless. Most popular types of direct sensor technologies: the CCD, complementary metal oxide semiconductor active pixel sensor. CCD is the most common image receptor used in dental digital imaging. Pixel is a small box or well into which electrons produced by the X-ray exposure are deposited. The X-ray photons that come into contact with the CCD cause electrons to be released from the silicon and produce a corresponding electric charge. CMOS APS. One manufacturer uses a CMOS APS sensor instead of the CCD. The chip is less expensive to produce and offers greater durability than the CCD. A computer is used to store the incoming electronic signal. This converts the electronic signal from the sensor into a shade of gray that is viewed on the computer monitor. The computer digitizes, processes, and stores information received from the sensor. and has a split screen magnification capability. Types of digital imaging include direct digital imaging and indirect digital imaging, meaning scanning traditional images and storage phosphor imaging. Direct digital imaging. Components include the intraoral dental X-ray unit, a sensor, and a computer with imaging software. A sensor is placed into the mouth of the patient and exposed. The sensor captures the image and transmits it to the computer monitor. Software is used to enhance and store the image. With indirect digital imaging, components include a CCD camera and a computer. An existing X-ray film is digitized using a CCD camera, and the image is displayed on a computer monitor. Storage phosphor imaging, a wireless digital imaging system. This is a reusable imaging plate coated with phosphors instead of a sensor with fiber optic cable. The phosphor-coated plates are flexible and fit into the mouth. A high-speed scanner is used to convert the information into electronic files. This type of digital imaging is less rapid than direct digital imaging. Step-by-step procedures. It is critical to refer to the manufacturer-provided instruction booklet for information concerning the operation of the system, equipment preparation, patient preparation, and exposure. Intraoral sensor preparation. Each sensor is sealed and waterproofed. The sensor must be covered with a disposable barrier because it cannot be sterilized. Rigid digital sensors, wired or wireless, must be covered with a disposable barrier sleeve. Intraoral sensor placement. The sensor is held in the mouth by bite block attachment or devices that aim the beam and sensor accurately. Paralleling technique is preferred. Advantages of digital imaging: superior grayscale resolution, reduced exposure to X radiation, increased speed of image viewing, lower equipment and film costs, increased efficiency, enhancement of diagnostic image, effective patient education tool, and eco-friendly tool. Disadvantages include the initial setup cost, the image quality, the sensor size and thickness, infection control, wear and tear, and legal issues. This concludes our video lecture.